Yeah, so this is, I think, a special symposium and a little bit of, I think, a transition of, in addition to the work that a lot of that I and John and actually Daniel and a lot of us have been doing on Zio, which is a library for asynchronous and concurrent programming in Scala. We've been working on something new called Golem, and we're going to be sharing that with you here today. And I think that's going to be also a little bit of a start of a transition for a symposium from just being about Zio and just being about Scala to being about developing cloud applications in general. Because I think always our motivation in creating Zio was really there was a set of problems we wanted to solve. And that was one way of solving them. And I think we've got something new that is another way of solving them that is potentially even more powerful and is potentially applicable to a much broader set of problems and set of developers and organizations. So we're really excited to share that with you today. And I think definitely in the future, we'll still have some Scala and some Zio stuff, but we'll also have other stuff as well. So with that, let me hand it over to John, the CEO of Zyverge, to introduce what we've been up to.
Thank you for that introduction, Adam. It's a pleasure to be here and to see such amazing attendance. Wow, I was blown away when I saw how many people are here. Wow, that's really incredible. Well, I think that the story for Golem Cloud actually starts with another person here, Daniel Vygotsky, sitting over there. The one with the beard. Well, actually, there's two with the beard. The one on the left-hand, on my left-hand side, who created a really great open source library that I know some of you in the audience know about, ZioFlow. And ZioFlow introduced this idea of sort of bulletproof workflows as a library in Scala. And workflows are these long-running processes that execute over time that are resistant to hardware failures because they use some sort of internal persistent mechanism. And Daniel did a great job building that library and getting it out there as open source. And one of the things that struck me when I saw the work that he did in ZioFlow is that there's a big, big idea here. It's not small, it's gigantic. And that idea is much of the complexity of modern day cloud development stems from the fact that our programs can be halfway through something and they fail. And we have to, if we're building reliable, scalable, distributed, stateful systems, we have to account for that possibility of failure. And obviously, there's lots of ways a program can fail. The one that I'm referring to is something like hardware failure, or the application is updated, or the machine is restarted, or there's a configuration change which triggers one of the above, or there's a network or some other type of issue like that that's not inside to the application. So applications can obviously throw errors and fail in their own ways, but then separate from that, the infrastructure that they're running on can fail and leave them in the middle of something. And to get around this, we go through all sorts of contortions. We write insanely complex event source systems and just on and on and on. The amount of complexity we build into cloud applications to solve that exact problem is enormous. In fact, to some degree, I'm not saying I don't want to trash talk databases here because databases have lots of purposes, but obviously one of the reasons that we turn to databases and we don't just store stuff in memory is because if we do store stuff in memory, it's not going to be around for very long. It's just going to go away and it's going to disappear unpredictably and chaotically. And this idea of being able to write a program that runs to completion, and maybe it never completes, maybe it just runs forever because it's like a loop or a server or something like that, is incredibly powerful and simplifying. And if you build in our case, it was a library, and the bad thing about ZioFlow was that it was only interesting to the Scala market. And the idea is so much bigger than that. Every person in every single programming language should be able to benefit from this idea of building a program and having it run to completion, no matter what happens with the infrastructure, and not having to worry about resumption and failure and recovery and building sort of finite state automatons that are deterministic, all the stuff that we do in order to solve that problem. You shouldn't have to worry about that. You should write your program, put it in a durable cloud, and it should run to completion. And that's where the idea for Golem Cloud was born. It is a durable cloud computing platform that is designed to be able to take any program that compiles to WebAssembly and execute it durably, whether that's over a few microseconds or milliseconds, or whether that's over days or weeks or months or perhaps even years. And it's just amazing. I think we've all had a chance to absorb this idea a little bit. And I can tell you, we don't have all the answers for everything. We don't know exactly how to do everything. But we all have this sense that, wow, there are incredibly simple ways to solve some of the most challenging problems out there today. Gigantic sort of, million line of code applications that use all these big complicated infrastructure components potentially have a much simpler solution that a smaller number of developers could come up with, and that could be deployed and put into production in weeks instead of maybe months or years. And it's awe-inspiring to see that. I think you're going to see a little bit of that in this live coding preview here, where we're going to live code a Golem application, but we're just starting, I think, to discover the boundaries of what is possible using technology like this. Keep in mind, Golem Cloud is early stage. So it is, it doesn't have the sort of polish or other features that it will eventually come to have between now, which is the developer preview, and our commercial offering of this, which we hope to launch early next year. So keep that in mind as you watch. There are a few rough edges, maybe more than a few, but nonetheless, I think you'll be pleasantly surprised by this is a new way to write software. It's new, but at the same time, one of the most interesting things is you don't have to learn a new programming language. You don't have to learn a new standard library. You don't have to learn any sort of vendor-specific framework. You just write a program. You turn a switch in your compiler to say, build me a WebAssembly program, and you deploy it in Golem Cloud, and it will just run to completion. So with that said, I hope you've enjoyed that whirlwind introduction to what Golem Cloud is and where it came from. And now I'll turn it back over to Zyverge's CTO, Adam Frazier.
Awesome. Thanks, John. Yeah, so before we get into the live coding, I'm just going to reiterate something that John posted in the chat, which is there's a Golem Discord, and that is a fantastic place for you to go to if you have any questions as we're going through that. We like to use the Discord versus the webinar just because the Discord is more permanent. So if there is a question and answer, other people can look at it later. And well, I'll probably be live coding, so I won't necessarily see all your questions right now. All of my brilliant colleagues here will be manning the Discord and can either jump in to answer your questions or can jump in to flag them to me, and we'll try to hit them as we go. So there's not like you're kind of wondering about something and then everything else is not making sense to you. All right, so with that, I am going to share my screen here. And all right, so what we're going to try to do here is walk through just about as from 0 to maybe not 60, but 0 to at least 30 experience of you're starting to work with Golem. You've heard John, you've read the website, you've downloaded the Golem application, and you're ready to, you want to do something here. You haven't done something yet. And the first thing that you'll notice here is it's Golem CLI. So right now, the way you interact with Golem is through this command line interface, which is always going to be one important way to interact for scripting or for CI or things like that. In the future, there's going to be much nicer visual interfaces coming. But again, as John said, we are in the process of building this out. So right now, we're going to use the CLI. You'll probably see me making silly mistakes as I type things into the CLI.
Yeah, could you increase the font size a bit?
Oh, yes, that is very important. How is that for everyone?
Much better.
All right, awesome, awesome. So the first thing I'm going to do, I'm just in the same folder that I downloaded here, and I can just do Golem here, and I got a nice little help and description here. And one of the features of CLI that we're going to use particularly here, and I'd really recommend you take a look at when you're starting out is these templates. And Daniel did a great job putting this feature together, but what this does is it gives you a whole set of templates for different languages that get you started. So let me actually use the command and show that. And so what you see here is we've got this whole set of templates. And one of the things you'll notice here is these are for a bunch of different languages. And so that gets to one of the really cool things about Golem and about WebAssembly is versus what we were doing before, where you had to write in Scala and you had to write in this like particular dialect of Scala. In this case, you get to write your application in essentially any language you want, technically any language that compiles to wasm and hopefully has support for the component model, which is a growing set of languages, but you get to use the language that you want to use and that you're already comfortable with. And so as you go down the list here, you'll see there are examples of using C, using Go, using Rust, using Grain, using JavaScript, using Swift, using Zig. So there's a whole set of languages that support, that compile down to WebAssembly, and you can use any of those languages. And if you go to our website, there's actually really nice documentation that Daniel put together that shows exactly what level of support each of these languages has. You'll see this tier, which is our categorization of how good their support for WebAssembly and the component model is. So like tier 2 is better, tier 3 is not as good. But you'll see we've got a whole set of things here. And for each one, we've got a template, we've got a description, which language is in the tier. And this whole library of templates is actually already open source. So you can go to it right now, and maybe someone wants to actually share the link in the Discord. But you can go there and you can even submit pull requests to add additional templates. I think one of our colleagues already submitted a pull request to add a new template. So this is a really cool way to get started, because as I think we'll see, there's a little bit of, depending on which language you are working with, there's just a little bit of like, okay, how do I target WebAssembly from that language? And what these examples are going to do is essentially give you that template so you can basically just copy and paste and work from there. So in this case, I'm going to work in Rust, relatively nice language, at least from my perspective. And I'm going to start with this Rust shopping cart example. So I'm going to go back down here and let's see if I get my commands right. So I think I need template, and I need a name of templates. This will be Rust shopping cart. And then I'm going to do this command component name. I'll call it just, maybe I'll call it my shopping cart. Just, I think I may have already created a shopping cart before. But what this component is you could think about it as your program. So a component is like a blueprint, and you can then deploy as many instances as you want that are going to run the logic that is in that component. So here, this component shopping cart is going to embody the code and the logic that initially is going to come from this template and that we're going to build on. So let's see if I got this right. It looks like I did. And we see we've got some nice information here. And so this is telling us, one, where it created the shopping cart. So it created it in this my shopping cart folder, which is great. And then it gives us this information that in Rust, the way that we create a WebAssembly program from a Rust program is we do this cargo component build release. And cargo is just the standard build tool for Rust. Component, we take advantage of something WebAssembly called the component model, which allows you to plug in different pieces of functionality, different components together for these WebAssembly programs. And then we're just saying that we want to build it. Daniel, is there anything more you want to say about the component model?
Yes, maybe. So WebAssembly itself is a very low-level virtual machine, a stack-based virtual machine, and it allows you to export functions. But for example, the only types it knows about are integers and floating point numbers, and everything else you have to do by by putting things in some linear memory. Component model is something that is currently a work in progress thing, built on top of WebAssembly, and it gives you a few things. For example, it gives you proper types, a type system, an interface definition language, and also specifies how these higher level types are represented by this lower level WebAssembly in this lower level WebAssembly world. So it defines an ABI, an application binary interface, which specifies how these higher level interfaces are going to be transformed into low level WebAssembly codes. And some of the languages that we support already have a quite good level of support for component model, which means that you can write these interfaces, and there is a ready to use tooling available to work with the interfaces, so you can just implement them in your chosen language. Some other languages are not there yet with the tooling, because as I said, this is something that is work in progress. But still, we can support those as well with some inconveniences. But Rust, Go, and C and C++ are the three which are having the best support right now for this world.
Yeah, and I think the really important thing to know about WebAssembly, other than that it enables us to do this stuff in Golem, is for you as a user, you don't have to deal with WebAssembly other than telling your language how to compile down to WebAssembly. We'll see this in a second when we do this, but like I'm going to do nothing with WebAssembly in this entire session other than basically type this command, which is actually not even in WebAssembly, it's just terminal command.
Yeah, it's just another compilation target. So
exactly.
You shouldn't really care about how WebAssembly looks like or what it does exactly. It's just something you can compile your program into.
Exactly. Okay, so this has this helpful instruction. I want to do this cargo component build release. And I need to do that from the folder where I've actually created my shopping cart. So let's just see what I've got. And indeed, I've got my shopping cart there. I think before I was playing around, I created another shopping cart, but that's fine. So let's go into my shopping cart here. And let's do this cargo component build release. And so it's going to go through the whole process of creating this thing and downloading everything.
While this is building, we did have a couple of questions here. Maybe I can answer real quick. One question is just,
please.
Are we using temporal IO as part of Golem Cloud? And the answer is no. Temporal IO is sort of in an adjacent space, the workflow space. And temporal IO is a really great product. And they went down the path of building an SDK in different programming languages to allow you to build durable executions, durable workflows, and great quality product. We are not using that. We're using sort of bare metal Rust basically on our back end in order to provide very efficient, low latency implementation of what is a fundamentally different approach to the idea of durable execution, one that allows you to use whatever programming language and whatever code that you want, and is also not necessarily just looking at the workspace or workflow space, but rather looking at sort of the space of how can we take any program at all, whether it's a workflow or not. Maybe it's more like a server in the sense that it accepts messages and processes them in a reactive way, and deploy that in a way that's 100% durable. So different approach, different technology, not based on temporal IO, even though temporal IO is a highly rated and I think industry proven way to deploy production workflows out there. And then one more question was, why aren't we using TypeScript? Well, if you want to, you can TypeScript work. So you can, you're more than welcome. We're going to add more templates over time. We probably should have some TypeScript examples as well. I'll go ahead and paste the repository where you can feel free to contribute your own templates into the Golem CLI. I'll paste that now in the Discord.
Yeah, open an issue or even better, a pull request. That would be great to add.
Yeah,
All right, so we see.
Primary reason why it's JavaScript and not TypeScript in the templates is my lack of understanding how to compile TypeScript to JavaScript, because I never did that. So it's definitely possible, I think.
Yeah,
And,
I think that's definitely
templates like that.
Yeah, I think that's definitely one challenge we've had as a development team, is because you can use so many different languages, we're having to do at least a little bit with all these different languages, many of which are not ones that we normally use. So it's a great, templates is a great area for people to get involved who are deep on TypeScript or whatever language you're into. Okay, so at the bottom here, you see this was successful, and it says it created this component. And it created the component in my shopping cart in this particular target, wasm release. And the important thing for me right now is this lib.wasm file. And so wasm is like web assembly, that's the suffix for that. And this file is basically the output of taking my Rust program that was in the template and compiling it down to WebAssembly. And what maybe makes sense to do now is let's actually take a look at this program here. So let me go here. And let me find this folder. We're in my shopping cart. And let me start by just opening this whole thing. And so let's take a look at what this template gave us. So there are really, I would say, two things that are most important here. There's this code, which is the Rust code that represents our shopping cart. And this you can think of as a reactive component here of what the shopping cart is letting you do. Is you can initialize it, you can add an item to it, you can move an item to it, you can update the quantity of an item with it, and you can eventually check out with it. You can get the cart contents with it. And you'll notice all of this is just written in normal Rust code. There's nothing special that we're doing here. The only thing that's a little bit weird in the case of Rust is we have this state thing. And this is basically just us for this example wanting to work around the fact that Rust really does not like you having global state, right? Rust is very much about memory safety, and Rust is not like you just having this like global state. But this is how we can do it. But I think the thing that's important to note here is there's nothing special or magical about this. This could be any Rust code at all. I could use a library for UUID generation. Maybe I'll bring one of those in. I could use a library for HTTP. I can use the normal things that exist in the language that I'm working in. And what we've got in addition to this Rust code is we've got this thing called a WIT file. And this gets back to some of the ideas that Daniel was talking about here, is the WIT file essentially represents the public interface of our component or of our instance. So here we're saying that this is how the outside world gets to interact with this worker or instance, or word you want to use for it, that we're deploying. And so here, first, we're defining a couple of different data types. So you can see that WIT is its own little language here, it has its own specification. And so we can have records that have multiple fields, and then we can have variants that have multiple possibilities. So here we've just defined a simple record for a product, defined a record for an order or a confirmation, and then the result can either be an error or success. And then these are the methods that the outside world can use to call our component. And this is a pretty, I think, simple language. Sometimes I get thrown off of whether it's a dash or an underscore, but otherwise, you can. I think these are pretty readable, right? You initialize the cart, you give it a user ID that's a string, doesn't give you back a meaningful result. You can add an item, remove an item, and so on. And so what's neat about this is that this interface, all these types that get defined here, automatically get carried over to the code in the language that you're working in. And so here in Rust, at least we do it by these imports. So we import this Golem component API, and that gives us Rust versions of each of those types that we defined in the WIT file. And so if we go down here, you'll see all we do to create our component is we implement that interface. So we have to implement those same signatures that we defined in the WIT file. And one of the things you'll notice about this, if you look at this code a little bit, is if this wasn't a Golem program, this would be almost comically wrong, because how are we maintaining the state of the shopping cart here? Well, it's just basically a string and a list of items. And it's just an in-memory list. So imagine that this is Amazon or something, and someone's ordered something, but then they left in their shopping cart, right? And they went and did some fun stuff in the weekend, and they came back on Monday and they checked on their shopping cart. Well, if this was the way you wrote it, probably when you go back to your shopping cart, you're not going to find anything there, because while you were doing fun stuff over the weekend, this server that this was running on got redeployed or what have you, and this completely got blown away. So if you had someone interviewing for a job and this was like what they came up with for like how they were going to manage the shopping cart, that'd be like probably not a good sign. And the reality is, like, you have to have a bunch of stuff of like, okay, well, we need a bunch of databases and we need repositories in front of them because we want to abstract over the databases, and we think about which ones are transactional with which ones, and there's a whole lot of stuff here. Versus this is almost, I mean, it's almost embarrassingly simple. And there's some stuff here that is Rust stuff that is not Golem stuff, of we're using this state thing and this with state thing to kind of get around Rust not liking global variables. But to initialize a shopping cart with a user, all you do is, well, we print a debug statement so we know we did it, and you just set the user ID to the user. To add an item, all you do is you just get the items and you push an item onto it. And so this is like very, maybe modulo the Rust, this is very clear business logic here. There's not us kind of intermingling this with thinking about all this stuff of like, when do we need to persist something? Or like, how do we deal with like, well, we're going to fall over at this point, and does that get us into a bad situation? Because when we recover, we see this thing, but we don't see this thing. It's just, no, we wanted to remove an item. Well, we're just going to go through the list and we're basically just going to filter and take out the item. We want to update an item quantity. We're just going to go through until we find the item, and we're going to set the quantity to the quantity we want. All of this is like super straightforward here. So what we're going to do in a second is, this is kind of what we already got. And maybe actually I'm going to switch back it to the Golem CLI, and I'll show how we deploy this. And then we'll go through and we'll actually start editing this so that we're like making our own application and not just using the template application. So I'm going to go back to the CLI here. There we go. And so now that I've got this component, or this code here, this is what I need to deploy one of these components. And so what I'm going to do is, maybe first I'll just go to my Finder window here. Just so, let's see, where's my desktop? Oh, I'll just go here. This danger of sharing the full screen. Let's see, can I make this larger? Okay, it's a little bit larger. All right, so I'm just going to go into my shopping cart here and take this target, wasm release, and this lib.wasm is the one that I'm like particularly interested in right now. And I'm just going to copy this. I'm going to move this up to the top level here, just so it's easy for me to work with it with the Golem CLI. And maybe I'll just rename this. I'll say this is my code, just so we see. So then when I want to actually upload this component, all I'm going to do is, first I'm going to go back to our folder here. And then I'm going to do component add. And then I'm just going to specify the name of the component. So I'll call this one shopping cart, or maybe I'll call it my shopping cart, just in case I create another shopping cart. And then I'm going to just specify this file here, which I moved it up. So I think I called it my code.wasm. I've forgotten that. Let's see. Oops. Yep. So see, I've already created my shopping cart. So I'll call this my shopping cart 2. All right, there we go. So now I've uploaded this component to Golem, and we can see it's given me some information about it, of like what's the identity of it. This is version 0, the first one I created, name, how large it is, and then it shows these exports, which you'll notice that's the same interface that we looked at before that came from the WIT file. So I know how I can call each of these methods. And right now, the way you call them is through the CLI, which is not as nice as eventually having a lovely visual interface, but that is definitely coming in the future. So now that I've got this, I'm sorry, go ahead.
Oh, this is maybe a great place to answer one of the questions, which is how do we query the items in a specific cart? And just sort of, well, for every one of these components, Golem instantiates a REST API that you can use to invoke any of these functions that are exported from any HTTP client. So that allows you to, for example, initialize a cart and perform add item, remove item, update item, checkout, and get cart contents. And then the other related question, which is, can we see all shopping carts? And that basically is equivalent to enumerating instances of a given component, which if we don't have an API for yet, we will eventually. That's a big data thing. So basically, there could be millions of given instances of a single component, or tens of millions, or even more. So that's not a small thing. You should think of that as being big data. But we will, if you don't already, we'll have an API that allows you to enumerate the instances of a given component. And then the other related question is, what's the mental model around code updates? And I think you can see that a little bit here is just that these components are versions. So every time you deploy a component and create an instance from a component, it uses the current version, or you could use the past version if you want. So in general, you're going to have lots of instances running. Not all of them will be with respect to the latest component version. And the other related feature, which you will want, and we don't support now, even though we will for commercial launch, is taking a running worker that's running at like version 1 and doing a live update of its code to version 2, for example, while still preserving its state. And that's, we're not talking about that because we're still figuring out details of how we want to expose that. But obviously that's important for a wide range of use cases involving very long running workers that need to have code updated either because you discovered bugs or you need to add new features for these workers which have not yet finished completion.
Yeah, and the mental model here is the component as like the blueprint. So this is not a particular shopping cart. This is the blueprint for shopping carts. And then if I want to, I can do instance add instead of component add. So I could do instance add. And now I say, well, I want to create an instance of this component. So this is going to be, I called this my shopping cart 2. And then I specify the name of the instance I want. So I need the 2 dashes. Instance name, and maybe this instance is Adam's shopping cart. So now this Atom shopping cart is an existing stateful Golem instance that is on the internet and is going to be around forever, or at least as long as known data methodologies exist, and that anyone with permissions can interact with. So I think this is another cool thing about Golem. There are a lot of analogies to it, right? You can think of it as like a stateful Lambda. You can think of it as a worker. You can think of it as a workflow. I think another interesting analogy is kind of blockchain, where clearly this is like way more efficient. It doesn't have the like trustless aspect of it, but it does have this aspect of like, you just get to deploy this thing, and this is now here forever for people to interact with. Unless in this case you can delete it. It's not like blockchain where it's like can't be deleted. But I think that's a really, really neat aspect of this. And then once we have this instance, we can do instance invoke, and we can actually call any of these functions with their arguments, and we can interact with that. And so that's how, if you were building a application, you would essentially, under the hoods, use this API. And again, it's available as a REST API as well as part of the CLI to create these instances and to interact with them. If you imagine that maybe you have some website where people can click a button to remove an item or to update an item, well, when they do that, then that fires off one of these commands to one of these Golem components. So now that we see how that worked, let's go back to looking at our code and see how we start to modify this to do something that is going to be a little more unique to us. Before we do this, are there any more questions?
Yeah, there's a couple more questions. Is there a concept of time to live to avoid the abandoned flows?
So there isn't today, but that's actually something that could really, I think, nicely be implemented as probably its own flow or worker or instance, where you can imagine every time you create one of them that gets registered, and there is a time you specify, and then it sends a message to shut this down. So that's, I think, definitely something that we could look at. And I think one of the things we're saying is like a lot of those management type features can be implemented as Golem instances themselves.
And another thing that might be worth pointing out is that workers that aren't doing active work are suspended. So it's not like they're actually running. I mean, it looks like they're running. You can still interact with them, but they're not actually running. They're not in RAM. They're not consuming CPU. So inactive workers don't have costs to you other than obviously storage costs in the cloud.
Exactly. Yeah, that's a great point.
And then another question, how do you achieve the invincibility of these workers? Can we really depend on this as much as the database?
Yeah, so that's a great question and gets to some of the underlying technology. And that's partly where WebAssembly comes in. So one of the things that WebAssembly gives us as the Golem team is it gives us this very sandboxed environment where essentially every WebAssembly program runs in its own virtual machine and only gets to interact with the outside world in any way with the resources that are given to it. So if I want to print something to the console, can't just do that in WASM. Can only do that through a console capability that is provided the program. I want to generate a random number in WASM. Can't do it except for a capability that is provided to the program. And so what that gives us the ability to do is have this very strong ability to introspect the program and see, as it's executing, all these points in which it's interacting with the external world. And then what we can do is a very smart form of snapshotting or capturing the state, where we capture the state of the application after all of those important steps where you're interacting. So we can give very strong guarantees about the fact that your program really will pick up immediately where it left off. If it's running on one server, that server is down, it's going to be picked up on another server and continue on without any change in the behavior that you see. Okay. Anything else, or shall we dive in here?
So much. So there's explosion of
All
questions.
right. Well, why don't we? I'm sure we'll have follow-ups, but yeah, we got to start some live coding, or we're not going to have any kind of application here.
Yeah, let's
so
start. I'll go ahead and reply to questions on the Discord while you code.
Okay, perfect. So what I thought would be fun for us to do is to kind of have like an auction app. So it'd be kind of an auction house where basically people can register as people who are bidders, and then you can list an item, maybe with an expiration time, and then people can place bids for it, and eventually when the time gets to after the expiration time, you can kind of close the auction. So another thing where state would be important, where definitely if we were not doing this with Golem, we would need a database, and where there are a bunch of things we have to think about consistency and order of operations and things like that. So I think what I'm going to do here is, and maybe let me just show you one more thing before we dive in here, is before I start breaking everything, let me go here and let me just do cargo component build here. And what you'll see is that, I mean, it's kind of implied by the fact that I was able to create the wasm version of this, but this is all totally valid code. I can do cargo component check here. So I can do normal workflows that I would do to kind of do my, to program this and develop this code as I go. Now, I think as we go here, I'm gonna temporarily not be compiling at all because I'm gonna blow up all this stuff as we kind of move from the shopping cart to our own thing. But let's start doing that. So I think I'm going to start with this WIT file because I think it's kind of nice to like start from the API. I think I'm going to call this auction, say action auction. And so maybe I will actually, let me just leave some of this stuff for myself here, just so I have a little hint for myself of, let's do some stuff. Okay. So if we have our auction, maybe we want one function that is like register bidder. And so I'm going to use this little bit, like, I think probably all of us will not program a ton in WIT. So this may be a little bit of like, we'll just figure out as we go, but it's pretty straightforward here. And so this, I think, is going to take a bidder name, let's say, which is a string. And I think that I'm going to want to give me back something you call like a bidder ID. And so maybe I'll create a new record for a bidder ID. And it's just good. It's simply going to be a wrapper around the string. And maybe I'll call this name. And maybe this ID will be more like a UUID. And then I'll capture the name as a string. And I should be able to, oops, what did I do? This one. Oh, and I renamed this, so I should rename this, yeah. Oh, right, I've added this function, I haven't implemented it yet, so that's fine. So let's do a few more. So why don't we say I should be able to list an item. And so this will be a function that will maybe take a name of the item, the description, starting price, and maybe something like a deadline. And maybe I can make that, I'll just use like seconds since the app block is my representation of the time here. So I can register a bidder, I can list an item. I probably want to be able to do something like get active items. That should give me back all the items, which is going to require that I actually have a data type. that is an item. So let me create that. That have a name, description, starting price, and deadline here. So I can register a bidder, I can list an item, I can get items. I probably want to be able to bid on an item, which is going to require having a item ID. Maybe I'll do the same thing. So my item will also have an item ID. And maybe I'll actually do the same thing with the bidder here. I'm not going to worry about them having the balance right now. All right, so I can bid, I can specify an item, the bidder, and how much I'm willing to bid. And then let me have something like, maybe I'll call this close auction. And maybe this is going to give me a bid result. And the bid result is going to be a variant. And maybe this will either be say just no winner yet, right? Where the auction is still ongoing, or the auction is closed, and here is the successful bidder. So I think that's probably a decent start at our interface here. Definitely anyone feel free to jump in and comment on my live coding. Always a fun adventure here. And so what we should see now is if I've done my WIT file correctly, which it looks like I have, I'm basically getting a bunch of errors for not implementing the API here. So I've got to fix those errors, but that's actually kind of a nice thing already, because that means that that WIT description here of the interface has been translated into Rust. And Rust is now just knows what these types and interfaces are, and it's just saying, hey, Adam, you gotta go ahead and you gotta implement this. So I'm just gonna do a little bit of renaming here. So I'm gonna call this auction.wit. And I'm gonna kind of change all these things. And then we're just gonna kind of go through and progressively fix our errors. So this will be auction impl. Let's make sure that I'm still compiling here. Yeah, okay, great. And so now what I'm going to do is I'm going to delete all these helper methods here, just because these are all specific to the previous version I was working with. And I'll call this auction impl. And now I've just got to go through and I've got to implement the interface that I had here. And I can even, let's see, I think I should be able to get a nice error message. Okay, so let's see. All right, let's take this out for a second. And then I think here. Well, let me go back to where I'm. Oh, yes. Okay, there we go. Okay, so let's go down to these. And so I can just grab this. Unfortunately, this doesn't give me the nicest versions of these with their parameters here. But so I think this was name. And this was the name, description, price. This was like deadline. Get items, just give it back the items. And again, what you're saying here is like at this point, I'm just doing Rust or I'm doing whatever language I'm in. Close the auction. I don't think we actually need any arguments there. We'll come back to that in a sec. One of the things I find as I'm doing this is it's a little bit of sometimes an interactive process of going back and forth between the WIT file and your actual code. And let's see what I've got here.
You need to use a dash instead of that, because it's not not a valid Rust identifier. No, in the other way.
Oh, we're here.
Yeah.
Oh yeah, yeah. See these dashes versus. It's going to be up between the WIT file and this. Okay. And then we don't have such thing as a product item, so let's get rid of that. And then let's have this. Okay, so we still got some nonsense here, but we're now compiling again, which I always feel like is a good place to be at. I haven't been compiling for a while. And so now we can start thinking about how we implement these things. And I think what we're going to find is like all the thinking we do is kind of thinking about our logic, and the actual kind of doing it is going to be, again, like embarrassingly simple. So when we register a bidder, so that means we need to have some kind of either list or map of bidders. So maybe I could use, again, I can use anything in Rust. So I could use something like standard collections, maybe a hash map here, and maybe I'll get rid of the user ID in a sec because that's a carryover. But maybe I'll say like bidders is maybe a hash map from, yeah, this string to bidder, let's say. And so that means I need to go down here. And I don't think I can quite do, we're going to have to do a little bit of a Rust thing here, because I don't think I can create a new, let's see. Oh, so first I thought I had a bidder here. Let's see. I do have a bidder, I think. And then I'm going to need that lazy thing. Let's see, do we have that in our dependencies? I think we do have the one cell. And again, this is just me getting around kind of Rust weirdness with having a map here. Oh, right, needs to be. There we go. Okay, so now I've got some bidders. And so now let's think about what it would mean to register. So we might want to have some UUIDs for our user IDs. So let's see if we've already got a crate for that. It looks like we don't. So let's see if I can add that. Check that's the right version. Okay. Oh, and I think I'm going to need version equals, and then I want this v4 thing just so I can generate random UUIDs. And so you can see that's a nice example of where I can just use a library, right? This UUID library doesn't know anything about Golem. It's just a Rust library that you would use. And I just pull it in and I can use it here. So then here, let me throw this in. All right, so let's say I want to register a bidder. So let's just say we're going to create a new bidder ID, just generate a new UUID, turn it into a string. And then we're going to, again, just for Rust, we're going to do this with state thing. Maybe I'll just put this around this whole thing just so it's easy. But we're going to do this with state. And this is basically going to give us this. This is kind of the syntax for like a lambda in Rust. But so we're going to say with the state here, we're going to generate a new UUID. And then we're going to insert into the bidders the ID we just created and the name. And then we're just going to, we don't even need the return here because the last thing is the return. We don't need that. Oops. What did I just scrub through? Oh, so this is a common mix-up to make sure you don't do. So I did cargo instead of cargo component. And if you do cargo versus cargo component, then it doesn't know about your WIT file and it doesn't know about any of these types. So then here, do bidder ID. Oops. It's called ID. And there you go. So there's our implementation of registering a bidder. It's again, other than the Rust stuff, it's dead simple, and there's no database involved, right? You don't need databases here because we've got Golem here that's going to make sure the state gets persisted for us. And we can go through and we can implement these other methods the same way. And each time we're basically just going to add any state that we need to. And again, in Rust, we'll kind of, at least in this example, we're using this pattern of kind of having this one state thing, but there's no need to have your state as just one thing. We could do like a Go example where you had pieces of state all over the place that was just like a counter getting incremented as part of some thing. So there's no need to put it all together like that. That's just kind of a convenience for Rust here. So we can imagine maybe we need another list of items here. So now we've got items as part of our state. And so then if I want to list my items. Okay, so let's create a new item ID, right? The same logic we had before. And then, well, what do? I just insert this in, and I've just got my item ID, name, description. I don't think we need this one here. Sometimes OpenAI is very, very nice, but not always right. And let's just check. I think, let's see. Oh, I think we called this This one I think should be limit price, or what do we call this? Almost an item starting price. There we go. All right, so then let's get the active items. And use the state. And so I'm going to get all the items. And then I don't think I want to use greater than 0. So this is a case where I'm going to want to bring in another function here. And so I think I'm going to want to bring in some concept of like time here. So let me see if I can implement a little helper method for that. Maybe I can call this like now. So I'm going to get the system time, and then I'm going to get the duration since the epoch, and I'm going to turn it into seconds. That's what I'm going to do. And so active items are ones where the deadline is in the future. So I think I should just be able to call now there. Great. And then if I want to bid, so I think we're going to need some other piece of state here. So maybe we have something like high bidders. And so this will start with a item ID, and then we're going to need a combination of the identifier of the current winner and the and the winning bid price. So now we've got some more state here. And again, like maybe we would want to refactor the state differently, but we don't really have to worry about that so much because this is all just state we're working with here that's going to be maintained consistently. We have to be really careful about our data model and making sure that we're handling everything in the way to support the exact transactions we need and things like that. So then here, if I want to bid, we can do get the state again. And so we could let's see. So we're going to get the bidder, we're going to get the item, and then we're going to look for the high bid. And if our price is above the high bid, then we're going to insert it. So I think there's this right here. Let's just there. And then, I don't need any. So let's see. So we've got our bidder ID. So I think we can just get the item ID. Then we're going to get the bidders. entity. I've got like less things here. Oops. That's that. And so that if we want to close the auction, and do with state. And so we could get the high bidders. So we felt first we could check the time. So we could say we're not bringing an item ID here. It's not a bidder ID. So that item is equal to get this item. Then say deadline. And then I think we had this with a slightly different name. We had it as no winner here. And else let's get a bid. And then I think our winner just had the bidder ID here. So don't need the price. Then why is it not finding this? Why is it not finding the bid result? Hale, do you know what I'm doing wrong here?
I was looking at Discord, so I didn't see.
No worries. I'm just trying to figure out why it's not picking up the bid result type.
One thing you can check is that this cargo component tool is actually generating a Rust file somewhere in the target directory, which contains all the generated code. So I usually get there. And this is what that tool generates, and I usually just look into here and find which module.
Yep, that's a good. All right, so we got a bid result.
It's probably in a different module that you didn't import. So if you just scroll up a little bit, there will be mode. Yeah, like mode exports, Golem component.
API.
And
API
it's called,
bid result.
yeah, so let's check the imports.
It's capitalization.
Oh, okay.
That's usually our source of problems. So let's go back here. So my bid result. Where do I have my bid result? Interesting. I'm surprised. Oh, here. That's what I should have done. See, this is silly stuff that screws us up.
Yeah, I see now.
So we got that. And then I think this one, when we were just calling success. And got there. Okay. And let's see, what's that field? Okay, now I think we just have this one. Oops. Let's get back to our. Oh, states would be a better idea. Something silly here.
It's because you use the success in this record initialization syntax, and then you need to specify a field name first and then the value. So
Yep. Let's see. I wonder what his field name is. Maybe I
yeah,
should do.
go back to that other file and you will see.
Yeah. Let's see. Success.
Yeah, so it's not using this
Oh.
record syntax. It's
Oh,
just
it's just
I don't know, is it called this other syntax?
Yeah, exactly. There we go. All right, and then we just got to finish this one. So let's not even worry about this. So we're going to get back an optional high bid. And so if we wanted to we can match on the high bid. And so if there is no high bid, then we'll insert ourselves. And otherwise, if our price is higher than the high bid price, then we'll add ourselves. And there we go. And so you can see, other than my silly stuff with Rust, we've now created all the logic for our auction here. Let me just go through shopping cart and just rename this to auction, just so we're kind of cleaner here. Oops, auction. Okay, we don't need this. Let's make sure it's still compiling. Oops, how did I blow that? Okay, what was that? Oh, so I'm making the same mistake I did a minute ago. So I need to remember to do cargo component check. There we go. And now I'll do that same for James gonna do. Auction. Great. This. Great. So now this is looking decent here. I've got my WIT file, which I think also looks decent. So at this point, I'm kind of ready to go. So now I can go back to where we were at the very beginning. And so I could do cargo component build release. Oops, I need extra space. Okay, so now I've created my new auction house wasm file. Again, didn't have to deal with the wasm other than doing the component instead of just the cargo. And now I can go back to my Finder here. And so now I've got a new lib.wasm that let me bring this up to the top level. And this now I should be able to call, let's say, auction.wasm. So I know which one it is. And then let's go back to the CLI. And so let's do the same component add, but now this component will be called auction. And we're going to use the auction.wasm, and we're going to make sure that I actually copied and pasted the right file. I don't know what I've got going on here. What did I do with my wasm? Well, try that again. All right, it's probably my end. Anyway, we'll try that down. But now that I have maybe there's something wrong with my program. But now that I have my program, I can upload it just like the one we looked at before. And then I can invoke it. And there we go. That's essentially how I go from not having anything and not having done anything to having my own component instance deployed and ready to go. So I think you could see that really all the complexity I was doing was either kind of my business logic of like how I wanted to kind of update, in this case, the state of the auction, or was kind of my dealing with the host language, the guest language, I should say. That's kind of what we call it, of like the language you choose to work in. And so sometimes that'll have its own thing of like here, we had like a little bit of Rust stuff that I tried to highlight for you, but you don't have to use Rust. You can also use Go, or you can use other languages. And so that's really a high level overview of what Golem is. And we're really excited to see what you build with it. And yeah, come to the Golem Discord, ask us questions there, and then please download the application and try it out. And again, give us your feedback. Are there any other questions that we should hit now?
Well, there were probably more than a dozen questions during. I tried to answer most of them, but maybe you could review them and cover what you believe to be the highlights, just so the video audience who will be watching this now has the benefit of those answers.
Sure. Yeah, let me take a look. So I'm going to go back to the Discord here. And let's see, 165, holy moly. All right, recording will definitely be available. And lots of people joining, which is awesome. Yes, we answered the question about temporal I/O. I've got the code updates. Yeah, so there was a question about how do you do this with like, where is this deployed essentially? And so the answer is eventually it will be deployed basically wherever you want. Right now, we use AWS, but eventually you should be able to do this in Google, in Azure, or in your own cloud. So that's coming. And yeah, right, in a private cloud. Someone was asking about that. There was a question of permissions. And so normally to interact with an instance, you have to have authorization to do that. And you can grant permissions at various levels for other people to interact with your Golem applications. There's a question about interacting with other components. And the answer is yes, you can interact with other components from one component. That's, we think, is actually going to be a really important use case in the future for Golem. Right now, you do that through the REST API, but there's going to be a runtime API coming that's going to allow you to do that directly. Yeah, lots of questions here. I think that probably covers most of them. It's really fantastic. Yeah, does anyone else want to share anything before we wrap up here?
Thanks so much for that live coding demonstration. I think that was really great. And also, I think it'd be interesting to sort of think about how we would create a traditional cloud application that can support maybe tens of thousands or millions of concurrent auctions, right? What would we have to do to put together a cloud application that can support that many auctions with tons and tons of people doing sort of concurrent bidding across all of the auctions that are happening, and making sure we don't lose any bids, and making sure we don't put in bids after the point where an auction has been concluded. And what you did, it took all of 30 minutes or so in order to come up with this. And then you're pushing all the complexity of Golem handling the sort of scalability, the horizontal scalability, and giving us these bulletproof guarantees that no matter what happens with the underlying infrastructure, these individual auctions that are all sort of concurrently executing are going to keep on running, and they're going to run to completion, and we're not going to lose any bids, and we're not going to allow anyone to bid after the point where the auction's been closed, and all these really, really tricky conditions that would be very, very difficult to enforce in any other environment. And I worked on projects like that, and many of them use combinations of relational databases and then caches, and then they've got event sourcing and finite state machines and the works, and they're ridiculously complicated. And yeah, they're bulletproof. That's industry proven, but it's just so much. And Golem Cloud is about rethinking that from the ground up and saying, why do we have to write all of this complexity? Maybe the alternative is to make our machines invincible, right? We don't program against real machines anymore. We program against ideal machines that never go down and that can scale sort of horizontally as much as we want. And that's a simple idea with profound, I think, implications. The next person who creates an eBay killer, it could be a person spending a week on it. I'm joking somewhat. I think that's an exaggeration, but this idea that any one of us as lone developers could go out and we could build something amazing that scales to handle any amount of users. And maybe we don't even use a database like your little auction program, no database. That's an amazing idea to me. And I think it really is going to shake up the foundations of cloud computing. And that doesn't mean that it's going to be used for everything. It doesn't mean that all the old stuff that exists is ever going to go away. That's not how computing works. But it can enable us to do more with less and go faster than we ever have gone before, and make the technology of creating big, complex, sort of distributed, scalable, stateful cloud applications more accessible to everyone, including lone JavaScript developers, right? Who can now create something that previously would require a 20-person team and 12 months to create. That sort of vision is what gets me really, really excited when I think about Golem Cloud. So like Adam says, please give this a try. It's early stage. We want your feedback. We want to hear about bugs. We want to hear about features that you want. If you think we're doing something wrong, we want to know that. if you want to contribute to our templates or contribute to the overall WebAssembly movement. So actually, Golem Cloud is just one of many startups working in the WebAssembly space. We're all saying WebAssembly is really, really interesting because of its capability-based security model and its sandboxing and all this multi-language support. It's really interesting, and it can use more help, more fans, and more people willing to sort of roll up their sleeves and contribute to these various open source projects. So please get involved, whether that's just as a tester of Golem Cloud or as a broader contributor to the WebAssembly ecosystem. It's a really exciting time to be involved in building cloud infrastructure because a lot of things are changing, and I think in a positive fashion. We're reinventing, at least we hope we're reinventing the foundation of cloud computing, and we hope all of you will join us on that journey.
Yeah, thank you so much, everyone. Have a great day.